Okay, so we're graphing parabolas. We'll start off very simple here. Y equals x squared plus 1. Okay. First of all, this is going to look very much like the parent function, y equals x squared.
Up 1.
The plus 1 that's after it, all it does is shift it up 1 unit. But let's be fairly specific and plot a few points. Okay. I'd probably make a little table of values.
0, 1. 1, 2.
0, 1, 1, 2.
Negative 1, 2.
Negative 1, 2.
2, 5.
2, 5.
Negative 2, 5.
Negative 2, 5. I'd call that pretty good. So I heard 0, 1, 1, 2, negative 1, 2, 2, 5, negative 2, 5, okay, which is going to end up looking just like you guys thought, okay, 0, 1, 2, okay, so y equals x squared plus 1. Perfect normal parabola, just like the parent function, y equals x squared. It's just been shifted up 1 unit because of the plus 1 that is after the x squared term. Okay? Any questions on that one? All right. Next one, ready?
Yes.
Okay. I'll do one more easy one here. Y equals x minus 3 quantity squared.
Quantities. Oh, as in like what's in the parentheses. Okay.
So what's this one going to look like? Will it still be in right side up parabola?
Yeah, left 3.
But you need to shift it
Up 9.
right 3.
Right 3.
Okay? Need to shift it to the right 3.
Oh yeah, you don't first FOIL it. Never mind.
Remember, in the parentheses, if we put x minus 3, it shifts it left or right opposite what you would think. So a minus 3 will actually shift it to the right 3 units. And does that make sense? If we plug in a 3 for x, do we get 0 for y? Okay? So this will be the what of the parabola?
Vertex?
The vertex of the parabola, the very bottom of the parabola. So this is going to be your vertex of the parabola. If you want some specific
1,
points,
4, 2.
no, you got 3, 0. I'd probably plug in 4 and 5 and see what you get.
Couldn't you, since you know that it's only to the right 3, couldn't you basically think of it relative to that?
Yep.
4, 1, and 5, 4.
4, 1 and 5, 4. So 4, 1, 5, 4. And then you know it's symmetrical, so I'll go back here on this side. Yes, you can just use the fact that you know exactly what the parent function looks like and shift everything right 3 units. That'll work however you want to do it. The table of values is not as important to me, okay, as is the graph and getting some specific coordinates correctly. Alright? So we've graphed those two multiple times, things like that very much, okay? Shifting them up and down, shifting them left and right. You've even done some where we've shifted them left or right, and then also up and down both, okay? So that should be pretty simple. If they throw a negative in front of this, what does it do? Makes it upside down, okay? Reflects it over the x-axis, and so on. All right? Now, this parabola and this parabola are both functions. Because why?
Because the x doesn't, or for each
Passes
x,
the vertical line test.
For each x, there's only one alpha.
For each x value, there is only one y value possible. All right, you can't plug in a 5 for x and get 2 different answers for y. Okay? For every x, there is only one y that goes with it, or it passes the vertical line test. All right? That'll still be the same even if it's an upside down parabola. Okay? If this is our equation, x equals y squared. Okay? Now we're talking about a sideways parabola, which will not be a function. Okay? When you have the y that's being squared and not the x, when you go to make your table of values, okay, again, when the y is what is being squared, when you go to make your table of values, plug in numbers for y. Okay? Plug in numbers for y, see what you get for x. Plug in, you gotta kind of switch it up here a little bit. If you plug in 0 for y, what do you get for x?
0.
0. What next number do you want to plug in for y?
1.
1. If you plug in 1 for y, what do you get for x? 1. 2 is fine. 2, if you plug in 2 for y,
4.
you get 4 for x. How about some negative numbers for y? If you plug in negative 1 for y, what do you get for x?
1.
Positive 1. And negative 2 for y?
4.
Positive 4. So then, when you go to draw your graph, if you go to plot all these points, 0, 0, 1, 1, 1, negative 1, 4, 2, 4, negative 2, you have a sideways parabola.
Oh. That's tricky.
Alright? You have a sideways parabola. This is not a function anymore. It does not pass the vertical line test. For every x value, there is not only one y value that goes with it. For instance, here I plugged in a 1, out came a 1. Here later on I plugged in a 1, out came a negative 1 as far as the x and the y is concerned. Yes, Emma?
Is there any way to put that into our calculator?
There is not, because your calculator does not have an x equals button.
That's right.
I take that back a little bit. You won't want to do this, but what you could do is you could solve this equation for y to get y by itself. To solve that equation for y, you'd have to square root both sides of the equal sign. Whenever you square root both sides of the equal sign, you got to have a plus minus on the other side. So when you square root both sides, you would get y equals plus or minus the square root of x. So then in order to graph it, you'd actually have to graph two different things under your y equals screen. I'd have to graph y equals positive square root of x, which would actually give you this part of the graph, the top half. And then when you graph y equals negative square root of x, it would give you the bottom half.
Okay.
So yes, kind of you can, but it takes two equations because when you get y by itself, you end up with the positive and negative. Okay? Some people think of it this way. You know that y equals x squared, the parent function, starts at the origin and goes up, right? So when they switch it around to x equals y squared, some people just turn their heads and look at it sideways, this way, and essentially graph the parent function looking at it sideways. Alright? It's a little bit tricky, doesn't always work when you start shifting, or it does, but you got to memorize some different things. I personally like the table of values, I think it's better that way, but again you can kind of do it however makes the most sense to you. Okay? Let's do x equals y squared plus 3. again, if you're gonna make a table of values, I would do it by plugging numbers in for y and seeing what you get for x. So anybody want to rattle a couple off or just one?
0 would be 3.
If you plug in a 0 for y, you do get 3 for x, yep.
Plug in a 1, you get 4.
Plug in a 1 for y, you do get 4 for x.
And then 16, 19.
What's that?
2 for, no, 4, 7. 2 would be 7.
So 7 comma 2, really?
And then negative 4 and 4.
Negative 1 for y gives you a 4 for x. And then I'm guessing it's probably right here. So there's the graph of that one. So again, kind of if you think of it as you're turning your head and graphing it this way, well, a plus 3 would normally move it up 3, and if you're looking at it sideways, up 3 actually means that way 3. Again, it can kind of be confusing. Some people don't like thinking of it that way, and it messes them up. Okay, but that's a way that can essentially it can work for you. All right.
What's the use of doing it that way?
Doing it what way?
Like, since you said, I mean, the way that we usually use parabolas is when, like, throwing things or doing one, are there examples when we'd use this in the real world, or aren't there any?
Well, probably have to be with what like the headlight example. You know, headlights are going to be more sideways parabolas because we want the light to shine out, so they probably had to figure out, you know, at what angle, you know, or how to make that parabola to make the light shine exactly where they want it
Like
to.
a dish be the same thing.
Satellite
kind of.
dish, they're actually a little bit
Well, yeah.
kind of cockeyed, but yeah. Again, they won't be straight up and down, straight left and right. We're not going to get into those complicated ones. We're really just going to graph very basic ones as far as you're concerned. But that's where I could see it being applicable, Luke. All right. How about x equals y plus 2 quantity squared? Go ahead, anybody?
0 for y, 4 for x.
0 for y would be a 4 for x.
9,
1 for
1.
y would be a 9.
1 for y would be 9 for x. I don't know if I got that much room. 4, 5, 6, 7, 8, 9.
2 for y would be 4, 16.
Yeah,
Would it-
not happening.
Would it
But yes, but I ran out of room. You're right.
negative 2,
Negative 1, 1.
Negative
1.
1.
oh wait, it would be 0,
Negative 2, 0.
Wouldn't it be 0, negative 2?
Yes.
Yes, but what can I get?
0, negative 2, yeah.
Wait a minute. Don't really look like I have a parabola yet. Let's keep going.
Negative 3 for y.
Negative 3 for y gives me.
So is this like when you have y equals x, it's just backwards, you think it's all here?
Say that again.
So like when you have, like, if y equals x something, it's like the same way it's backwards, when you think it would go up, it goes down.
Kind of in a sense, yeah. Mm-hmm.
Negative 4.
But this one is actually like if you turn sideways, it goes how you think it would go.
Yes, yep.
9.
Alright? So again, I personally like to make the table of values, plug in numbers, plot those points until I can get that parabola to look nice, symmetric, things like that. There are little shortcuts that some of you will figure out, which is great, okay? And we've talked about it, you know, a little bit, how you just can't turn your head and think about it that way. It's not perfectly the same, so I don't know, it's always good to use, but this is the extent to which we'll graph these, all right? We won't make it any harder than what you've seen so far today, all right?
Wait, how long are the videos supposed to be?
So very, very simple.
Yep, very simple. I'm going to give you 5 problems. Some of you might have them done before you leave, but these 5 problems are your homework problems. Alright, so do those 5 problems for your homework. It should be good on as far as what we'll do graphing parabolas wise.
What's all?
Could I just
Yeah.
write down the